Hello friends, in this video I am going to discuss the technique for sketching hyperbola. Let us start. Hyperbolas can be sketched from their standard equations using four basic steps. First step is determine whether the focal axis is on x-axis or on y-axis. First of all, we have to determine whether the focal axis is on x-axis or it is on y-axis. For this, we will locate the minus sign in the equation. This can be done from the location of minus sign in the equation. Okay. This is our first step. Now, the focal axis is along x-axis. It is along x-axis when the minus sign precedes the y squared term. Okay, it is along x-axis if minus sign precedes the y squared term. Okay, for the equation x square by a square minus y square by b square is equal to 1. Minus sign is before y square term. So focal axis will be along x-axis and it is along y-axis when the minus sign precedes the y square term. Okay, precedes the x square term here. Okay. The focal axis is along x-axis when minus sign precedes the y square term and it is along y-axis when minus sign precedes the x square term. This is our first step. We have to determine whether the focal axis is on x-axis or it is on y-axis. This is our first step. And in the next step, determine the values of a and b. Okay, by comparing with standard equations, we will now determine the values of a and b. Then draw a box extending A units on either side of the center along focal axis, A units on either side of the center along focal axis, and B units on either side of the center along conjugate axis. Okay, then we are going to draw a box. See here. If this is the focal axis is along x-axis, then A units on each side of the center along focal axis and B units on each side of the center along the conjugate axis. Then we will draw a box. Okay. Determine the values of A and B and draw a box extending A units on either side of the center along focal axis and B units on either side of center along conjugate axis. This is our second step. Okay. Now draw the asymptotes along the diagonal of the box. Okay. Now see here. First we will draw this box. Then we will make these two pair of lines which intersect at the center. Okay. These two lines we are going to make along the diagonal of the box. These two lines are the asymptotes. Now using this box and this pair of lines which are asymptotes, we can now trace our hyperbola. Okay, we know this distance will be tending to 0. This is the meaning of asymptotes. So we will make like this hyperbola. Okay, so that the distance of the point from this to this line tends to 0. Same way here, and here also. Okay, and it passes through this box, this point. Okay, this point. This way we will now sketch our hyperbola. Okay, using the box as a guide and the asymptotes, sketch the graph of hyperbola. Clear? Okay, now let us understand this with the help of some example. Okay. First we have a remark. A hyperbola in which A is equal to B. A is semifocal axis and B is semi-conjugate axis. A hyperbola in which A is equal to B is called the equilateral hyperbola. Okay. In the hyperbola in which we have A is equal to B is called the equilateral hyperbola, and such hyperbolas always have perpendicular asymptotes. Okay. Such hyperbolas always have a perpendicular asymptotes. Clear? Let us start with examples. Now, Sketch the hyperbola, label the vertices, foci and asymptotes. Equation given to us is x square by 16 minus y square by 4 is equal to 1. Now we have a minus sign before y square term. So focal axis will be on x-axis and conjugate axis will be on y-axis. Okay. Now the minus sign precedes the y square term. So focal axis is along x-axis. This is our first step. Okay. Now the second step is to find the values of a and b. Okay. From the denominators, in the equation, we obtain a square is 16 and b square is 4. Okay. Now a and b are positive. So this implies a is 4, b is 2. Okay. Clear? Now we will draw a box so that and take a units, 4 units on each side of the center along x-axis and 2 units on each side of center on y-axis. Okay. Since vertices lie a units on each side of center on focal axis, it follows that their coordinates are 40 and minus 40. Okay. These are the coordinates of vertices. Okay. We want to label the vertices, foci and asymptotes. Clear? Now, A is 4 and B is 2. Okay. A is 4 and B is 2. See here. A is 4 and B is 2. Okay. And focal axis is along x-axis. This is focal axis. This is focal axis on x-axis. And this is conjugate axis on y-axis. Okay. Now, A is 4 and B is 2. So, 4 units. This center is origin. Now, 4 units on each side of the center along x-axis and 2 units on each side of the center along y-axis, which is conjugate axis. Okay. Then, we will draw this box and draw these two diagonals also. Okay. Now, these two diagonals are the asymptotes. So, keeping this in mind, we will now trace this hyperbola here and same way here. Okay. And the points are, this vertices are 40. Coordinates of vertices are 40 and minus 40. Clear? Okay. Then this will be the graph of hyperbola. Clear? Now, equation of asymptotes. Equation of asymptotes. These two lines. Asymptotes. This can be, we can find this by taking 0 on right hand side. Okay. X square by 16 minus y square by 4 is equal to 0. This will give us y square by 4 is equal to x square by 16, or y square is equal to 4 by 16 into x square, or y square is equal to 1 by 4 x square. That is y is equal to plus minus 1 by 2 into x. These two are the equations of asymptotes. Okay. Now we also want to find the coordinates of foci. Okay. Now the foci lie C units on each side of center along focal axis, which is x-axis here, where c is square root of a square plus b square. That is 16 plus 4, that is square root of 20, and it is equal to 4.5. Okay, so 4.5 here and here. These two are the focus. Okay, 4.50 and minus 4.50. So coordinates of foci will be plus minus square root of 20, which is 4.50. These are the coordinates of foci. And this is the graph of the hyperbola. Clear? Okay. Now come to next example. Now consider this. 9y square minus 4x square is equal to 36. We want 1 here. So this will be 9y square by 36 minus 4x square by 36 is equal to 1. This will give us y square by 4 minus x square by 9 is equal to 1. Okay. Now minus sign is before x square term. So focal axis will be along y-axis. Okay. Now the minus sign precedes the x square term. So focal axis is along y-axis. Okay, focal axis is along y-axis. And from denominators we get, by comparing with standard equation, we get a square is 4 and b square is 9. And a and b are positive. So a is 2 and b is 3. Okay. So we know focal axis is along y-axis and a is 2, b is 3. Clear? Now we will draw a box extending 2 units or a units along y-axis on each side of the origin and 3 units on each side of the origin along x-axis. Okay. This way we will now draw the box. Focal axis is along y-axis and conjugate axis is along x-axis. This center is the origin. Now 2 units on y-axis and 3 units on x-axis. Okay. Now then we will draw this box. Okay. Draw the diagonals and keeping in mind that these distances tends to 0, as the point move away from the center, we will now make the graph of this hyperbola like this. Okay. These two are the asymptotes. Clear? Now asymptotes will be y square by 4 minus x square by 9 is equal to 0. This implies y square is equal to 4 by 9 into x square, or y is equal to plus minus 2 by 3 into x. These are the two equations of asymptotes, and foci will be c is equal to a square plus b square, that is 4 plus 9, that is square root of 13, which is 3.6. So foci, coordinates of foci will be 0 plus. So coordinates of foci will be 0 plus minus root 13 or 0 plus minus 3.6. Okay. See here. This is the center at the origin. These vertices are 0 plus minus 2 and foci is 0 plus minus root 13. And these two are the asymptotes, and equations are y is equal to plus minus 2 by 3 x. Okay. This is how we will draw the graph of hyperbola. Okay, clear? Now that's it for this video. If you have any queries or any suggestions, please write to me in comment box. Thank you.